Welcome back to Hardwood Home Lab, everybody. I'm Kyle, and today I'm going to be playing with a ZimaBoard 2 from the company Icewhale. I'm going to show how this little computer arrived, the software that was pre-installed, and what I think of it. Then, how I destroyed it all to turn it into a Proxmox backup server. If you're interested in seeing how I do this, then come check it out. So let's just kick things off with a disclaimer. Icewhale sent this unit to me for review and no money changed hands. They have no input over what I say or do with this hardware, and they will only be able to see this video at the same time as you do. They have no editorial control. So all thoughts and opinions in this video are my own. With the disclaimer out of the way, let's have a look at this thing. The ZimaBoard 2 is a really interesting bit of server hardware. This little computer sits somewhere between a Raspberry Pi and a desktop PC. So taking a look at it, this fun-sized computer is home to an Intel N150 4-core processor, and the unit that was sent to me has 16 gigabytes of DDR5 RAM. There is also an 8 gigabyte version available. Unfortunately, the RAM in both of these units is soldered on, which means you won't be able to upgrade it later even if you wanted to. This PC also features some eMMC storage. There's 64 gigs of storage on the 16 gigabyte version and 32 gigs of storage on the 8 gigabyte version. And both of them come with ZimaOS pre-installed out of the box. On the front side of the unit, you can see there's a mini display port. There's two 2.5 gigabit Ethernet jacks, two USB 3.1 Type A ports, and the barrel jack for the power adapter. On the back side of the unit, there are two SATA 3.0 connectors and a SATA power connector that the included Y cable uses to supply power to any connected drives. And finally, on the side of the unit is a PCIe Gen 3x4 slot that's conveniently open on the back so it can accept larger cards. The single board computer design is similar to a Raspberry Pi, but without the GPIO pins and the need to buy a separate case and power supply. And of course, the more traditional x86 CPU architecture, along with the SATA and PCI connectors, is more like a desktop PC, but without the bulk of a desktop case, and it avoids the expansion limitations of a mini PC. By the way, if you want to purchase one of these, the folks over at Icewhale gave me a discount code to pass along, so if you're going to buy one, you can use the code HardwoodHomeLab15 for a $15 US discount. Even though I don't get any kickback for any purchases made, I do have a link to the website in the video description if you are interested. The package that I received came with a mini display port to HDMI adapter, a tiny fan, a metal cage that the ZimaBoard 2 can attach to that also holds two 3.5-inch hard drives, a cable to relocate the PCIe slot to the side of the cage, along with a mounting bracket for half-height PCIe cards, a cable that they call a SATA Y cable, a PCIe card with dual M.2 NVMe ports that can accept all lengths of drives, plus all the screws and specialty tools needed to put it all together. Basically, I got everything you need except for the drives. And have you seen the price of drives lately? AI has driven the cost through the roof. So in order to buy drives for this setup, I had to sell a kidney. It was kind of tough to find a buyer who was willing to pay the price that I was demanding, but in the end, I got what I needed. Not to worry though, my wife is recovering nicely. I even managed to convince her that the surgery was a life-saving procedure, even though she never saw a hospital. Drugs are amazing. Anyway, I used the money to get two 12 terabyte NAS drives and two 1 terabyte NVMe SSDs. When it was all put together, this is what it looked like. It's really strange gear, but if I'm honest, I kind of like it. Even the cable tail. This unique sort of inside-out design is what gives the ZimaBoard 2 the flexibility that it offers. I really enjoyed putting the whole thing together. It was pretty straightforward, but there were no instructions in the box. As I was writing this script, I looked around and found that there are videos here on YouTube that show how to put it together in case you are unsure. Now that I have all of this assembled, I can play. To be perfectly honest, it wasn't originally in my plan to show the pre-installed operating system on this little beast, but after playing with ZimaOS, I felt I would be shortchanging you if I didn't showcase it a little. ZimaOS brings self-hosting into easy mode. After booting up the ZimaBoard 2, you're greeted with this display that shows you the IP address that you can access the web UI from. Using the web UI, the first thing you do is create a new account. Once logged in, you get a prompt to download the Zima client. Now, the Zima client is for connecting to your new quote-unquote cloud from anywhere. Under the hood, it uses zero-tier overlay network technology to allow connections to your new server, which I've used for years now, and it works great. But unfortunately, this app, like so many others, is only available for Windows and Mac, so us Linux users have to source our own. Fortunately, a quick search from the browser reveals there are community open source alternatives for us. Once you're logged in and at the dashboard, it's a good idea to configure your storage first thing. The gear on the storage widget brings you to the storage tab in the settings. While setting up the storage for use is really easy, for new users, the UI does try to show the benefits of each type of RAID configuration, but it doesn't recommend what should be used. Of course, these RAID benefits are assuming similar capacity drives. In my case, I created 2 mirror RAID pools. One 12 terabyte pool with the spinning disks, and one 1 terabyte pool with the SSDs. Then under the Apps tab, you can change where Docker data is stored. In my short run of testing, I found that the app data is where the smaller files are stored, things like the configuration files. I moved this to the fast storage pool on the SSDs. The app image storage is where Docker images will be kept. And during my testing, I found storing this on the spinning disks is significantly slowing down the deployment of Docker containers. I would recommend keeping this on fast storage. The user database storage is somewhat misleading. It's where all the larger files will be kept. Things like media and downloads are stored here, and of course databases too. And with those changes done, ZimaOS is ready to use as an all-in-one home server. Using ZimaOS's App Store, within about a half hour, I was able to install and use a handful of applications that I use nearly every day. The process was as easy as clicking Install for most programs. In a couple of cases, there were conflicts with the ports, and I was prompted with a display where the settings were easily changed so the applications could be quickly deployed. You only have to change the host port and the web UI port to match, and the application installed fast. I even installed Olama and ran an LLM. I had to search out the smallest models out there, but this tiny low-powered processor did way better than I expected. The ZimaOS web UI has a really nice system monitoring tool that kind of shows the CPU and RAM usage of the applications. Plus, it even has a link to BTOP, so you can view it from right in the browser. Using ZimaOS as a NAS is also really easy, as long as you want to use Samba shares, since the web UI doesn't support any other protocols. Which, to be honest, for most people, Samba is all they really would use. Within the Files utility that's on the dashboard, you'll see the directory structure on the device. To share the storage, click the 3 dots on any folder and select Share via Samba. The next pop-up allows you to select which users have access using a username and password, or you can select Guest to allow anyone, and you can set the read and write privileges for each user. Keep in mind, all I'm really showing here is a highlight reel of my experience, and it's not intended to be a comprehensive review since I haven't run this for any extended period. But from what I have seen, I am really impressed, and I would highly recommend it for anyone that wants easy mode for self-hosting. Plus, this is a really great NAS option for most people. But that's not what I need. With the storage available on this server and the low power usage, this makes an ideal Proxmox backup server. To install Proxmox Backup Server, I have downloaded the ISO image of the installer, and I used Fedora Media Writer to create a bootable USB. If you're on Windows or Mac, Balena Etcher or Rufus are also great tools for doing the same thing. While the ZimaBoard is booting, When the Zima logo shows on the screen, pressing F11 will bring up the boot menu. From here, you can select the USB drive. That will boot you into the Proxmox backup server installer. The graphical installer is very good, so just select that. Click I agree on the end user license agreement page. For OS storage, I'll be installing with a RAID 1 configuration, much like I did on ZimaOS earlier in the video. You can do this by clicking on Options and changing the file system to ZFS RAID 1. The installer will want to use all the drives by default, and you only want to install Proxmox Backup Server on the SSDs. So just click on Deselect All, then choose Hard Disk 0 and Hard Disk 1 as either of your NVMe drives. After both drives are selected, you can hit OK, then press Next. Choose your country, time zone, and keyboard layout, and press Next. The next screen is for the root user settings. The password will be very important. The email, maybe not so much. It's only used as the receiving address for notifications, so unless you're going to configure an email service, you can use a phony email. If you change your mind down the road, you can easily modify this from the web UI. Press Next to get to the network configuration page. For some reason, this page doesn't fill in automatically from the DHCP server, which I find a little bit irritating. The hostname field has to be a full domain. If you don't have one, you can use pretty much anything. pbs.home.lab, for example. Whatever you want, just as long as it resembles a website address, basically. Fill in the IP address, which will be the IP of your Proxmox backup server. The gateway, which is typically your router IP address. And DNS server, which is usually your router IP as well. I also needed to change the network device that I was using for this install, since my network cable is connected to this port. I found that out via trial and error. Then click Next and Install. It takes a couple minutes to install Proxmox Backup Server on the NVMe drives, and then when it's done, you click Reboot. Once your new server is rebooted, you can access the web UI from your browser by typing in the IP address of your server in the address bar and specifying port 8007. You're probably going to get a warning message from your browser that there's a security risk in accessing this site. That's simply because Proxmox Backup Server is using a self-signed certificate in the SSL encryption of the web UI. You can safely ignore this warning and proceed. On the login screen that pops up, you'll have to sign in as root using the password that you used in the installer. Now, the first thing I'm going to do, since I don't have a valid subscription for this machine, is I'm going to enable the no subscription repository for Proxmox Backup Server. To do that, you need to navigate to the shell. In here, you can use any text editor to create a proxmox.sources file in the etc/apt/sources.list.d directory. In the file, you want to paste this content, which I just grabbed right off the PBS server installation page. Then, after you save that file, you'll want to disable the enterprise repository to prevent any errors while updating your new server. You do that by using a text editor again to change the etc/apt/sources.list.d/pbs-enterprises.sources. That was a mouthful. It'll be on the screen, so you don't have to follow that. At the very bottom of the file, add a new line that says enabled false. You are now ready to test the changes by updating APT. I had 71 packages that were out of date, so I ran an APT upgrade to make sure everything was fully up to date before continuing on. Now that your server is up to date, the next thing you'll want to do is configure storage so that you have a place to store your backups. The hard disks I have were used to test out ZimaOS, so I'll have to wipe them before I can initialize them. If your drives are new, you shouldn't need to do this step, but you will have to initialize the disks with GPT before you can use them. Then under the ZFS tab, click Create ZFS, and you should be able to create a new ZFS pool with your drives. You'll have to give it a name, which will be the name of your data store, as you'll soon see. Since I only have 2 drives, I chose a RAID level of mirror, which is the same thing as RAID 1. Select your drives and click Create. Once it's done, you'll see a new data store is added. Since I have more than one Proxmox server and they're not clustered, I like to add a different namespace for each server. This will prevent conflicts if there's 2 VMs with the same ID numbers on the different servers. To add a new namespace, you simply select your data store, click on the Content tab at the top, then click Add Namespace in the upper right. I like to give the namespace the same name as the Proxmox server, but you use whatever makes sense to you and select Create. Your backup server is now ready to use, and the final steps are done on Proxmox. After signing into Proxmox, you'll need to select Data Center and then Storage. In here, under the Add drop-down menu, you should select the option for Proxmox Backup Server. You can call it whatever ID you like, and the server line will be the IP address of your backup server. Because I left everything at the default settings, the username will be root@pam, and the password will be the same as the one you set in the backup server installer. Enter in the data store and namespace to match the ones you just created, and if your memory is better than mine, you'll paste the fingerprint in before clicking Add. To get the fingerprint, you need to go back to Proxmox Backup Server, and on the data store summary page, click Show Connection Information. You can conveniently click Copy next to the fingerprint and paste that into the Proxmox Storage pop-up. This time the Add button will work. Now that you can use your backup server, it's a good idea to automate your backups. You can do that by selecting the Backups tab and add a new backup task by clicking Add. Select the virtual machines that you want to back up and give it a schedule. I set this one to run a weekly backup. It's also a good idea to have some retention settings in place that will match your needs. Click OK, and your backups are now automated. The final step is probably the most underutilized and arguably the most important. It's time to test the backup. Since there aren't any backups yet though, click the backup job that was just created and click Run Now. This will probably be the longest backup job since everything is being copied to the backup server, but from here on, only the changes will be uploaded during subsequent backups. I ran a second backup job just to show this. After the first one completed, the second backup job took only a few seconds to complete. Now that you actually have a backup, you can test it by restoring one. The backups can be viewed under the storage icon on the left side of the screen and selecting Backups. Now, to truly test your backups, select one and click Restore. Since I still have the original VM, the Backup Restore pop-up created a new VM ID number to restore to. You can change that if you want, but since I'm going to delete this after the VM is tested, I just left it as is. Once the backup is restored, you should start it up and make sure that everything is working the same as the original. So that's it. My new Proxmox backup server is up and working, and more importantly, the backups have been tested. I've only shown the default settings for Proxmox backup server and they work, but I'm still playing around to find the best settings for a more secured server. If you're interested in seeing what I come up with, let me know in the comments section down below. In the meantime, I'd like to thank you for joining me today, and I look forward to seeing you in the next one.